Alright, I accidentally closed the file, so restarted, and we are good to continue. So this will probably be a two-part video. So most of the questions on this side are repeats from the previous lesson. I'll go over just problem 1, and you'll try problem 2. Then I'll try problem 3, and you'll try problem 4. So we are given that cosine of an angle is negative radical 8 over 3, and the angle theta is in quadrant 3. What is the exact value of sine of theta in simplest form? Simplify all radicals if needed. So we are going to draw our circle. We know we are in quadrant 3, so our angle is going to start in standard position and end somewhere over here. We know that cosine is negative radical 8 over 3, so that is our x value. So negative radical 8 over 3, comma, y. We don't know what y is, but that is our sine value. So that means this distance here, which is our x value, is negative radical 8 over 3. This is on the unit circle, so this is 1. So we can use the Pythagorean theorem to figure out what y is. So we just take negative radical 8 over 3 squared plus y squared, because that's what we don't know here, equals 1. So this will become 8 over 9 plus y squared equals 1. If we try to get y squared by itself, we get y squared equals 1 minus 8/9 is 1/9. So we get y is equal to 1/3. So that means because y is sine of theta is equal to 1/3, we can then figure out what the angle is. Oh, was that all we were asked for? We were asked for the value of sine theta. But if we wanted to know what the angle in that right triangle is, we can also do theta is equal to sine inverse of 1/3. All right, this is what we were asked for. But if you were asked for theta, this is how you would find it. So theta is, just to help you with the previous homework if you're having questions about it, let me just get my calculator. Second sine of 1/3 is 19.47. Okay, so this particular angle of theta is 19.47. If we wanted to figure out the rest of the angle that made this entire angle, we would add 180. So that would be 119.48. Anyways, try the other example on your own. Moving on to problem 3 here. It says, using the identity sine square theta plus cosine square theta equals 1, find the value of cosine square theta if the value of sine square theta is, the value of sine theta is negative 0.2. This is around our answer nearest hundredth. And it says our answer should be what does it say? Between pi radians and 3 pi over 2 radians. So this pretty much says between 180 and 270 degrees. And that has to do with where that sine value is. So if we were to make our circle here, we're told that sine of theta is equal to negative 0.2. So we're either over here or over here, right? Because this is 0, this is pi, this should be half pi, and this one should be 3 pi over 2. So either we're drawing this triangle or we're drawing this triangle. But they pretty much said that we should be between pi and 3 over pi, so that means we're going to be over here. Which means our x value, which is what we don't have, because cosine is our x value, we have our y value. Our x value has to be negative. So when we answer this question, we're just going to say it's negative regardless of what it says. So we're told sine is negative 0.2 squared plus our unknown, which is cosine square theta, equals 1. 0.2 squared is 0.04 plus cosine square theta equals 1. Subtract the 0.04 to the other side. Let me just make sure I'm not crazy. And if I use my calculator real fast, 0.2 squared is definitely 0.04. Subtract that from 1, and on my calculator it gives me cosine square theta is equal to 0.96. I'll take the square root of both sides and get that cosine theta equals the square root of 0.96 is 0.97. It says round to nearest hundredth, so 0.9797. So the 7 here will round this up to a 0, which will make this cosine square theta. Cosine square theta equals 0.980. All right, so that is our x value for our value there. And now because we're in this quadrant, that value has to be negative, so it should really be negative 0.980. All right, you can try problems 3 and 4 on your own. Problems 2 and 4 on your own. Let's take a look at the back for some other uses of identities. All right, so these, it says to write each of these as a single expression. So I'm not going to do any of the problems. I'm just going to do the example problems. So I'm given cosecant squared minus cotangent squared. So I want to write that as a single trig function, or a single trig expression. So I'm going to start with sine square theta plus cosine square theta equals 1, and I'm going to change it in such a way where I have cotangent in my problem. So I'm going to divide this one by sine square theta. Because this will make cotangent. And now I get 1 plus cotangent square theta equals cosecant square theta. I want to rewrite this as a single expression, so I'm going to move the cotangent to the other side, and I'm going to get 1 equals cosecant square theta minus cotangent square theta. So as a single expression, this thing is equal to 1, so 1 would be my answer. Okay, and all of these problems, 5, 6, 7, and 8, are all similar versions of that. So that's using the Pythagorean identity, but next are reciprocal identities. You can also simplify these. So if I was given sine theta times cosecant theta, I can rewrite that as a single trig expression. So I'm going to write sine theta, and I'm going to replace cosecant with its reciprocal, so that's 1 over sine theta, and that's going to equal sine theta over sine theta, which is equal to 1. So that would be a single expression written from two things being multiplied. Pretty much you turn your reciprocals into other things. You can also change tan and cotangent and so on into sine over cosine. So that's for multiplying. I'll show you one more example with division. So I have tan square theta over secant square theta. I'm going to rewrite this as sine square theta over cosine square theta. I'm going to rewrite secant square theta as 1 over cosine square theta. So that's just using the identity of tan and the reciprocal of secant. This is a division of two fractions, so I can rewrite that using keep change flip. So we'll have sine square theta over cosine square theta times cosine square theta over 1. The cosines cancel out, and I'm left with sine square theta. So that would be a single expression. So try examples 9 through 12 using those two examples to help you. Then there's two problems to try from Regent's examples. All right, I hope this made sense. If you have questions, ask.